All right. Need to consider systems that have other bases. You know, our system, base 10, is all fine and good, but what if it was a base other than 10? We need to explore that a little bit. Think about that a little bit. One thing to point out, though, that in base 10, the symbols, again, we've already said 1 through 9, 0 through 9. And it should be noted here, how many symbols is that? How many symbols does base 10 have? It has 10 symbols, doesn't it? If you count 1 through 9, and then you got the extra one, 0 at the front here, that's 10 symbols. Well, turns out, if I go to another base, say I do a base 5. Well, in base 5, instead of having base 10, in base 5, guess how many symbols I'm going to need there? I'm going to need 5 symbols, yeah. Well, you start at 0, yes. And to get 5 symbols, we're only going to go up to 4, yeah. So actually in base 5, you're not going to have 5s or 6s or 7s. Yeah, you stop when you have 5 symbols in base 5. So that means you stop at 4 as far as symbols go. Okay? Or base 8, you're only going to have 8 symbols. And so that's going to be 0 through what? 0 through 7. Yeah, because that'll give us 8. Because 1 through 7 is 7, and with the 0 you got 8. All right, so that's the first thing to point out there. Different about other bases. If you have a base less than 10, you're going to have less symbols. Base 5 only has 5 symbols, and so that means when we do base 5 numbers, we're only going to have these. The numbers are only going to be made up of these numbers here. Base 5 numbers, you don't have any 5s or 6s. In base 8, you don't have any 8s or 9s. So anyway, that's the first thing to point out. So yeah, let's talk about a let's go ahead and talk about for example, a base 5 number. Well, a base 5 number, one such one might be 3, 2, 4. And to signify it's in base 5, they'll write as a subscript the base that it is. So 324 is base 5. And notice I didn't say 324. You can say that if you want, but it does not turn out, it is not equivalent to 324 as we think of it. But 324 base 5. Now one thing about it, and that's why I talked about just previously about expanding. When I expand this number, base 5, the deal is, since I'm in base 5 now, I won't have powers of 10. That each one of these digits here is multiplied by something to a power. However, since I'm in base 5, doesn't it make sense that it's going to be powers of 5? Because that's our base. So each one of these, and I'll just write, first of all, it's 5 to a power that these are multiplied by. 2 is going to be times the power of 5, and 4 is times the power of 5. Yeah. So that's the thing. When you change the base, you change what each one of these digits is multiplied by. It changes to whatever the base is. If it was base 10, these are 10s. But we're in base 5 now, so these are 5. So each one of these is multiplied by power of 5. Now, what power of 5 are we talking about? Well, the good news is it works the same way as it did with base 10 numbers. At the back here, what power did we start with? The 0 power. Same thing here. The back one will start with power of 0. So this will be 5 to the 0. Then what would be next? Power of 1, power of 2. So, yeah. So expanded, since we're in base 5, it's 3 times 5 squared, 2 times 5 to the first, and 4 times 5 to the 0. Now, what that does, too, is that gives us a way to also convert to base 10. If we expand this and then actually write out these numbers and multiply them out, what that turns out is it's the base 10 number that this represents, or this is equivalent to. Because if I multiply 3 times 25, right, 5 squared is 25. 2 times 5 is, it's just 2 times 5 to the first, 2 times 5, and then 4 times 5 to the 0, that's 4 times 1. If I multiply those together and add them, 75, 10, and 4, I get a different number. I get 89, right? That is the base 10 equivalent of my base 5 number that I started with. Okay. Well, what should be noted is, yeah, that's a much smaller number. And yeah, the smaller the base, the more digits it takes to write it. Okay, so 324 base 5 is only equivalent to our regular number 89 because it's a smaller base, so it takes more numbers here. That's basically one gist of it. Okay? All right, so if I say 89 is the base 10 equivalent of 324 base 5. It's just the here's how the question will be asked. Write the number in base 10 or decimal. I think maybe how they say it in the book. All right, so let's say I have 3, 6, 1, 5, 2. The base is 7. Write that number in base 10. Well, how do we write this number in base 10? We did what? We expanded, right? So we're going to expand. 3, 6, 1, 5, 2, base 7. To write that in base 10, I'm going to expand it. Okay, so that means take 3 times what it's multiplied by, 6 times what it's multiplied by. Okay, so we're in base 7. So each one of those is multiplied by power 7, isn't it? So 3 is times the power of 7. So is 6 times the power of 7. Moving away. Just those too far apart there. So forth and so on down the line, right? Each one is going to be multiplied by power 7. Now, if we want to, let's go ahead and fill it in. What power of 7 is 3 by? Be the 4th power. How do we know? Start at the back. That'll be the 0 power, 1 power, 2 power, 3 power, 4 power. Yeah. So 3 is times 7 to the 4th. So 6 would be 7 to the 3rd. The 1 is times 7 to the 2nd. 5 times 7 to the 1st. And 2 is times 7 to the 0. With me on that? Yeah, so then you just, do your powers of 7. Probably most of these you're not that familiar with, but 7 to the 4th is 2401, so it's going to be 3 times 200401. 7 to the 3rd is 343, so it's going to be 6 times 343. 1 times 49, 5 times 7, and 2 times 1 it would be. With me there? So just multiply those all together and then add them up. I'll do it all at once here. 6 plus 49, that'd be 35, and 2. I get 9,347.
I get 9,359. Oh, but it's because the last one I took 2 times 7, which was 14.
Okay, there you go. All right. 9,347, I do believe. Okay? All right. Do it one more time just to make sure. 9,347. Okay. So in base 10, that long number there, 36152 in base 7, is only equivalent to this. Okay. All right. Now, what if, we talked, well, let's talk about base 2 for just a second, because it's actually a pretty widely used base. I mean, it's not nearly as much used as base 10, but base 2. For base 2, symbols-wise, what do we got? 0 and 1. Base 2, you only need 2 symbols. And you do start at 0, so 0 and 1. Base 2 only has zeros and ones in it. So when I see a base 2 number, it's just a string of ones and zeros. Okay? Looks like a pretty big number, doesn't it? Well, let's see about that. What is that in base 10? Well, we need to expand it, right? Expand that base 2 number. Oh, by the way, also to throw another term at you here, base 2 numbers are also called binary numbers. You may have heard of those. Computers, lots of things now run on binary code. But anyway, what is this binary number here, base 2 number in base 10? Well, we need to expand it, don't we? We need to take each of these ones and zeros and multiply it by the base 2 number that it is, right? Expand it. Okay, what would just so happen this one right here, the very first one on the left, be multiplied by a bit? Well, it's base 2, so it's power of 2. What power of 2 are we talking? Well, if we go back to the end, it starts at power 0, 1 power, 2 power, 3 power, 4 power, 5, 6, 7th power. So we're all the way up here to the 2 to the 7th power. Then that 0 would be times 2 to the 6th. The second one from the left would be times 2 to the 5th. Then we'd have another 1 times 2 to the 4th. Then another 1 times 2 to the 3rd. Then we'd have 0 times 2 to the 2nd. The 0 times 2 to the 1st. And then the last one on the right is times 2 to the 0. With me on that? Well, it just so happens 2 to the 7th is 128. So we have 1 times 128. 2 to the 6th is 64. 2 to the 5th is 32. So it's 1 times 32. 2 to the 4th is 16. So it's 1 times 16. 1 times 8. 0 times 4. 0 times 2. And last but not least, 1 times 1. You think the 0 power is 1. Well, also you might note, since we have a lot of zeros there, we've got a lot of zeros in our, or actually just, some of these are just 0. This will be 128, but that'll be 0. That'll be 32. That'll be 16. That'll be 8. That'll be 0. That'll be 0. And that'll be 1. So there's a lot of them that zero out. So we actually just have 128 plus 32 plus 16 plus 8 plus 1, which that would be how much? Somebody got it? 128, 32, 16, 8, 1. Somebody tell me what they get there. Or you may just do it. That's 160 and that's 25, so I think it's 185. Somebody check me on that. Make sure. Okay. So yeah, this long string of ones and zeros there, if it's base 2, is just 185. Now, the reason base 2 is so significant is because, you know, computers deal with switches, on and off. Switches are on or they're off. 0 for off, 1 for on. So that's, yeah, it's very useful for things like that anyway. So, but as far as numbers go, it does take large, long strings to do small numbers even. But anyway, relatively small numbers. Okay. All right. Well, that's base 2. Now let's go the other way. We talked bases smaller than 10. Let's talk about what would we do for bases bigger than 10? What about a base of 12? Well, since we're talking a base 12, how many symbols do we need? 12 symbols? Yeah, we need 12 symbols, but starting with a 0, so we need 11 more. 1, 2, 3, 4, 5, 6, 7, 8, 9. That gets me 10, but I run into a problem. Because really, when I'm talking the symbols, I only want one symbol to represent each number there. And when I get to 10, the number after 9, that's 2 symbols. I only want one symbol to represent 10. And the way we do that is we pick up with letters. Capital A. Capital A is going to be the next symbol in base 12. Now, capital A has a value of 10. Okay? It does mean 10, but it is represented by the letter A. So that gives me how many? That gives me 11 symbols, so I need a 12th one. Okay, so in base 12, the symbols are 0 through B. 0 through 9, and then A, and then B. A more utilized one, because it's a power of 2, is the base 16. So what would be the base 16 symbols? Well, you got 0 through 9, which is 10 symbols, and then you need 6 more. So we need what? A, and B, C, D, E, and F. So the base 16 symbols are 0 through 9 and then A through F. So if you get bases bigger than 10, yeah, you got to resort to letters. Okay. Now, what does that mean when we get a base 12 or a base 16 number? Let's do a base 16 number. All right, let's say I have the base 16 number. Oh, let's do 3, 4, D, C, base 16. Looks a little funny, but that is a number. In base 16 it is anyway. What is that in base 10? Well, same deal. I'd want to do a bit of expanding. Expand that out. Since I'm in base 16, each one of these is by power of 16, right? We know that much. Each one of these is by power of 16. What would the 3 be power of 16? Well, we start with the back. 0 power, 1 power, 2 power, 3 power. 3 would be 16 to the third, times 16 to the third. 4 is then times what? 16 to the second. The D would be times 16 to the first, and the C would be times 16 to the 0. With me on that? Okay. Now, though, we have a slight problem. Yeah, I can do 3 times 16 to the third is how much? 16. Now, 16 to the third. Yes, raise that to the third power, 4,096. And then 16 squared, I believe, is 256. But there's no D on our calculator. So what we have to do there is actually convert it to its number equivalent. Like we said, A is worth 10 always. B then would be worth 11. C is worth 12. D is 13. So it always starts at A is 10, so you just work your way up from there. D is worth, what do we say, 13? 13. So it'll be 13 times 16. What about C? Well, A is 10, B is 11, so C would be 12. And then 16 to the 0 is 1. Yeah, so when you convert the numbers to base 10, you need to convert the letters to their numbers.
Going back down to 1098 and 1. From A, 1098. Is that what you're saying?
Yes. Okay. So let's go 3 times 4,096 plus 4 times 256 plus times 16 plus 12. We got it? 13,532? I believe is what we get. Question? You got 13,528? Try it again then.
Yeah, 5.
13,532 is what I get. Okay, C is 12 because A is 10, B is 11, C would be 12. 16 to the 0 power, anything to the 0 power is 1. Yes. Okay. All right.